review for our statics exam, our midterm exam. And this very short video is added onto the number 18 video that I put on your Moodle page. So this one will actually be called number 18 for statics. So you'll have one lecture 18, which is about a half hour long, and then this, which is just a few minutes long. So this is in addition to the rest of that material. I was just saying that for statics, the process is that chapters 1, 2, 3, and 4 would each have a homework problem, but that the chapter 1 is really just that unit conversion handout. So from your Moodle page, I pulled up the conversion factor worksheet, and I was looking at what I would like you to do for a conversion factor for the first problem. So I like the rates problems, rates, areas, and volumes from the worksheet. And on the worksheet, let's come back over here. There we go. There are 8 problems that are involved in that. So if I were going to choose a conversion that I would like you to do, I believe it would be most similar to number 2, okay? So in other words, that problem is to convert 550 centimeters per minute to feet per second. And the reason I like that is you have to convert both the meters and the feet, or excuse me, the centimeters to feet and the minutes to seconds. So it's sort of like a two-stage conversion process. So that would be the problem that would substitute for chapter 1 on statics. Now chapter 2 in statics talks about the statics of particles, and the chapters 3 and 4 are going to involve they're going to have one three-dimensional problem. So the problem I would choose from chapter 2 would be a two-dimensional problem. And I also like to choose something that's fairly classic. In other words, something that doesn't look odd or strange compared to other problems that you've worked. So the problem that I'm looking at for the example problem for chapter 2 is in the review section of your text, and it's number problem 2.132, where we have 2 cables tied together at sea, loaded as shown. Knowing that the maximum allowable tension in each cable is 800 newtons, determine the magnitude and largest force P that can be applied and the corresponding value of alpha. All right, so this is a really good trigonometry problem. The only difference is that when you have to check tensions here in 2 cables, you really have to work it out twice. So I would do a problem very similar to 2.132, only I would just have a condition on one of the cables instead of both of the cables. So it might just say, knowing that the maximum allowable tension in cable AC is 800 newtons, or something like that. So this is our first problem. Our second one, an example, would be 2.132. Okay. The other thing is I will do both metric, or SI, and U.S. customary units on the exam. I'll also try to keep the problems as generic or down to earth as possible, just because we don't need to complicate things or try to look at something brand new in this particular exam. Now, on chapter 3, we are talking about moments and forces. And one of the things I'd really like to emphasize in this chapter would be the vector mathematics. So I would look at a problem, maybe even just, I think I'll do a pure math problem from this, where you just have to find some vector sums, and vector maybe a dot product and a cross product of a couple of vectors. So I'm kind of looking around to see if there's something where I might have to just do a composite problem, which is not that big of a deal. But let me see. I think what I'm going to do is going to give you, for chapter 3, I'm going to give you 3 vectors and ask you for maybe a dot product and a cross product and maybe a mixed triple. Okay, so that's just going to be, and I'll give you 3 vectors before we end our time together here today. So in other words, we're going to do a dot product, a cross product, and a mixed vector product. All right. And so then last but not least, we have chapter 4. And chapter 4 is equilibrium of rigid bodies. So as we've discussed before, these are 3-dimensional problems, and they are quite involved mathematically. So I would like to give you one that is, none of them are simple, but that is relatively straightforward, where you have to do a 3-dimensional problem that will work out relatively easily, that you can set up kind of easily, and then the math will fall out. And those are always interesting to find because they're not always, sometimes they look more straightforward than they are. In your homework, I had assigned problem number 106. And I may have done 105 on one of the videos. So when I look at that, I really like the problems in that vicinity because they kind of accomplish a lot of the things that I would like them to accomplish in terms of visualization and so forth, and in terms of the vector work. So I kind of think I would choose as an example problem 107, which is very, very similar to 106, just one of the dimensions has changed. So those will be the problems that will be used for review. Now, on the problem 3, for chapter 3, I need to give you 3 vectors in order to do the vector math. I also wanted to make sure to see if I wasn't forgetting something else here that I wanted to remember. I don't see it though, so I think I'm okay. Okay, yeah, I think I'll just do that. All right, so let's say for number 3, just for practice, the vectors would be P, Q, and R is a bad choice because it looks like resultant, but I don't mean it as resultant. I just mean as some other vector. And let's just say P is 6i plus 4j minus k. Q is 2i minus 3j plus 4k. And R is negative I minus 2j minus 3k. All right? And so those are the ones that you'll do a dot product, a cross product, and a mixed triple product of. All right. So at this point, do you have any questions? No? Good? Okay. Good. I will attempt to make the test as straightforward as possible. I would never say easy because I know they're not easy, but I will do my best.
Will it be similar though to like the stuff we've done in the homework?
It will.
Like if we can do that.
Absolutely. Yep, you'll be good. And especially if you follow like the format of the quiz. I'm not going to ask you like draw a free body diagram, tell me what theory you use, but I mean kind of think that way because that's the level of engagement that I would like to see. All right. Oh, and if you have an equation solver on your calculator, I still want to see the determinant and the solution of the determinant. You may want to check your answer with your calculator, but I still want to see the steps. All right. All right. Well, thank you for your attention, and I will be sending out an email today telling you the times that you can come in and take your exam. If you've already scheduled one, it'll just be that. But there will be like 4 times that you can come in. And some of my students have 2 classes with me. So if you do out in Camerland, if you have more than 1 class with me, you just come in at you would come in at 2 different times, but you don't have to tell me ahead of time which test you're taking each day. I'll have both of them ready, and you can just choose which one you want to take at one time and then take the other one at the other time. All right. Well, best of luck, and as usual, do not hesitate to get a hold of me if you need help with something.